Hello, good evening to everyone joining us on Space or Live. Welcome to another episode of the Space Talk in Season 4. Tonight on the show, we've got an incredible guest on tonight. We've got Dr. Piers Horner, who is an astrophysicist, space fanatic, and author of his first book, Short Stories of Space. Thanks everyone for joining us, whether you're here on YouTube or Facebook. Thanks for spending your evenings with us. If you're watching this on catch up, remember to let us know if you have any questions in the comments section below. Wonderful to have you on the show, Piers. How are you?
Evening. Yeah, not too bad. Thank you. How are you?
Yeah, good. Raring to go for another great talk. So everyone who's joining us, just to let you know, we're going to be talking about the book. We're going to be talking about Piers' experiences writing the book. And we'll be having lots of chit chat about space later on. And if you guys have any questions throughout the talk, please do let us know in the comment section or on YouTube or Facebook. Well, welcome to the show, Piers. I usually start off the talks by kind of asking you your experience and your background. But since we've got a very special thing we're talking about, which is the book tonight, let's get straight into it.
Yeah.
What's it about? What is Short Stories of Space about?
Well, Short Stories of Space is a collection of 7 short pieces. They're inspired by events in space and astronomy from 2020. So I wrote most of the book in 2020. They're sort of a mixture, really, of the actual science behind each of these topics. So there's 7 topics that I'm covering there. The science behind each of those topics, but the way in which they weave into other themes that are around kind of history or around society, around politics, all this kind of stuff. So they seek to go kind of beyond just the science itself. They seek to tell a much broader story about these different topics. Yeah.
And who, when you were writing it, you mentioned kind of the different topics and themes you weave into. Who is the book for? Who are you thinking about?
Well, the book started out as actually being for a very general audience. So the people I had in mind really were sort of people who had a general interest in science, space and astronomy, but probably got most of their news about space and about astronomy from mainstream news. And really what I kind of wanted to do to start off with was pick up on some of those stories that didn't quite make it into the news headlines and yet were really important, and kind of really try and pick those up and kind of say why they're important, why people should be excited about it, and again what it means for broader society, for history, all this kind of stuff, like into a bigger sort of theme and a bigger context as well. But it kind of evolved actually whilst I was writing. So I started off with that ambition, and then, to be honest with you, as the year was going through, I was kind of trying to identify different topics that I wanted to write about, of which there were many, of course. Yes. But whenever I'd identify a topic, it would sort of take on a life of its own, and it would become its own thing. So I started out with this ambition of sort of championing sort of slightly smaller research, as it were. I think where I've ended up is really sort of hopefully 7 quite personal, quite detailed actual stories about space and about astronomy that are quite rich in themselves. So I think it's a bit of a mixed bag, but hopefully they're all interesting.
Great. Now, I'm sure they will be. And if you're just joining us, we've got Dr. Piers Horner on the show tonight. We're going to be talking about his first book, Short Stories of Space. And later on during the show, Piers will actually be going through all of his 7 topics with some really cool space imagery, which I'm really looking forward to. Now, before we came live backstage, we were just chatting about how you were a space fanatic growing up. Why is that? Like, what inspired you about space?
Well, I think space has been like a massive part of my life since I was a really small child. So, I think like many people, when you're a kid, kind of growing up, looking at the sky, I mean, it's just a thing of wonder. But actually for me, the thing that I really remember when I was about, I think 6 or 7 years old, I'm not sure if my parents are on the stream, so they could probably add in the message to say how old I was at the time. But I'm not sure. Anyway, when I was 6 or 7, I remember doing a school project about space, and I hadn't really sort of been exposed to astronomy prior to that. But actually, I read an encyclopedia this idea that the universe was somewhere between, I think at the time the estimates were around 12 to 14 billion years old, and to small 6 or 7-year-old Piers, that was pretty mind-blowing. And just that sheer concept of that much time, and the universe being that big, that ancient, just really, really blew my mind. And that just got me hooked, really. I was hooked from then.
Yeah, hooked enough to actually go on to do a PhD in astrophysics. Is that kind of the inspiration just carried on throughout your school career?
Yeah, it really did. I mean, I sort of I learned as much as I could. I was really fortunate to actually be able to join a really good astronomy society. So a very small shout out to Cardiff Astronomical Society, which was a really great place to sort of meet other astronomers, learn much more about astronomy, obviously. I was definitely one of those slightly annoying youngsters who thought they knew, everything about their topic, and, was like the world expert in astronomy, and used to go around asking annoying questions of other people trying to give talks. And then just carried that through into university, really, and into a PhD, into research.
Great. And then what actually inspired you to write your first book?
Well, so even though I went through into research, I decided actually not to continue with research in the end. It's a long story, which is a completely different kind of story. But I ended up taking time out from research, and I allude to it in the foreword of the book. Actually, I had a little bit of a personal crisis in which I sort of lost some of my enthusiasm for science, which was really like a hugely sad thing. But it was really nice that after a few years, I began getting it back again and began developing again. And really, Short Stories of Space is kind of has emerged from that, really. The sort of genesis of the book itself, so to speak, is actually the very first story in the book, which is on the right shoulder of Orion. I wrote back at the start of 2020, and it was in response to, I'm sure you guys will remember, and possibly quite a lot of people listening to this will remember, that around late 2019 and into early 2020, one of the brightest stars in Orion, which is called Betelgeuse, suddenly started to fade and dim very dramatically. And there was a huge amount of response about this. People were getting very excited about it. People thought that, or some people thought, that actually, it was possible that Betelgeuse itself, which is a massive star, was actually on the verge of collapsing and exploding and turning into a supernova. And everybody was excited about it. And, I was excited about the idea of the star exploding and this being a spectacular event. But I actually noticed that I had a sadness inside myself. And when I sort of reflected on that, it was actually to do with when I was a child. Orion was literally one of my favorite constellations in the night sky. I absolutely loved it. And the idea that actually one of the most characteristic stars in Orion would die and disappear and completely transform the nature of that constellation turned into something that actually I felt really quite sad about, and a sort of bereavement, and I couldn't help but just write about it. And I ended up writing this story, which is probably the most personal story actually of the book, about how my relationship with this constellation, it was about the fading of Betelgeuse, but really the story was actually about my relationship with the constellation of Orion itself, which is a weird thing to say, I admit. But that was the first story, and from there I was kind of like, actually, I really enjoy this. I think there's something I can say here, and I'd really love to do more of this. And I just went from there.
Great. So you almost had a personal attachment to the first chapter.
Yeah. Absolutely. As I say, it's funny, isn't it? Our sort of relationship to the stars, to the constellations. I think space and astronomy is for me is one of the most human sciences, because it's part of it is about that process of kind of looking up to the stars and placing yourself in the universe, and what does it mean to be alive in this universe, and all that kind of stuff, right? But in doing that, so part of that is philosophical, but part of it is emotional, and it's about your attachment actually to these stars, to the heavens, to the universe as a whole, and that's, as I say, something that I ended up writing about. I ended up kind of enjoying exploring, I suppose, and I thought was actually quite an interesting take on this story, which in the news headlines had all been about, will Betelgeuse explode or not? And actually for me, it was more about, will I lose this connection to actually a childhood favorite constellation? And as I say, when I say that, it sounds a bit ridiculous, but it was genuinely a fear for me, and genuinely a kind of sense of, my goodness, I really don't want this to happen,
Wow, that's crazy. That's crazy. I've never spoken to anyone who has that sort of connection with constellation, and so much so that you've actually dedicated the first chapter of your book to it. That's wow. I don't know what to say. That's crazy. Well, what about the other 6 chapters then? Where did the inspiration or attachment come to? What did you dedicate those 6 chapters to?
Well, so they're not all, as I say, quite as personal as that one. But I mean, when I go through the slides a little later, perhaps I can talk a little bit about each of the chapters, as it were, and what they try to cover. But I mean, what I was looking for throughout the year, so I was writing throughout that year, 2020, keeping on top of research that was coming out, speaking to the people who were responsible for that research. Because obviously, I'm trained in astrophysics, but it's been a while since I've been in it. So it was really, good to be able to actually speak to researchers themselves and make sure that, I fully understood what was kind of going on. But it's hard to describe, because I think, each of the stories basically touched me in a slightly different way. And as I say, maybe not quite in the personal way in which that first one. But I mean, they range. So I mean, there's one of the stories, which is Earth's Unlikely Twin, which starts out being about the sort of detection of, or the potential detection of, phosphine in Venus's atmosphere, which again was something that was publicized or hit the headlines quite a lot last year. But it ends up actually being about habitability in the solar system, and the fact that actually Venus, Earth, and Mars, potentially in the early solar system, were all habitable planets, and we're now down to just Earth. And it was interesting that in sort of talking about phosphine in Venus's atmosphere, you actually ended up talking about places in which life could exist in the solar system, and how actually that's reduced from 3 down to just 1, which is our planet Earth. And that's kind of a scary thought. But it's also a sort of thought which, for me, very much kind of makes me go, we just, even more reason why we need to actually protect this planet and look after this planet. It just makes Earth all that more special. So each of the stories had like a different angle on them, but I had to feel that in order to write about it, and there are a lot of stories I could have written about last year. Loads of things, obviously, that happened in space, but not all of them, connected with me in that kind of way. Where I saw the connection, that's where I wrote about it.
When did you know when to kind of cross the topic off?
Well, sometimes I started like trying to write about a topic, thinking, you have a germ of an idea, and let's explore it, let's research it, let's develop it, and it just doesn't go anywhere, or it just doesn't hit the note that you wanted it to hit. So there's definitely a process of does this speak to me? Is it, and as I kind of actually write it, does it continue speaking to me? Does it send me in a particular direction? If it didn't, then I had to scrap it, because it wasn't delivering what I felt needed to be delivered in these stories.
Great. And then what did you mentioned kind of the research you had to do and speaking to other researchers whilst writing. What did you learn during your research that you were kind of like, oh wow, I didn't know that?
Oh goodness me. Well, it's funny because I think so. A couple of bits really. So solar physics was not something that I was that I specialized in when I was actually studying and in my early years in research. So I actually ended up speaking to some really lovely people from the sort of NOAA. Goodness me, momentarily forgotten the acronym, but an institute in Japan who actually led a whole bunch of kind of solar physics research, and learned a lot about solar physics from him, which was really lovely, very interesting. Also, the Aurora, which is also related to the same story as the solar physics bit, was not something that I particularly knew much about when I was kind of as a researcher, but a really fascinating, complex kind of area. How charged particles from the sun interact with charged particles in the vicinity of the Earth. How the magnetic fields of both Earth and Sun kind of interact, and how that leads to these really beautiful kind of light shows that we get on Earth, obviously. So that was really cool.
Great. Just a shout out to everyone tuning in. Thanks, Ground-Based Space. Thanks, Jamie, for tuning into our talk tonight. Once again, if you guys have any questions for Piers, let us know in the comments section and we'll be sure to answer them later on. One final question before we move on to speaking a bit more about the 7 chapters. If someone from the audience tonight is to ask, what will I kind of achieve from reading the book? What would you say to them?
I really think, what I've tried to do with each of the stories is, where we're talking about something that was actually reported on in news headlines, is actually produce a really alternative view. So I've already talked about Betelgeuse and the explosion of Betelgeuse. It takes it in a completely different direction. To that. There's one of the stories, the last story actually, is about the Crew Dragon, right, and the launch of the Crew Dragon last year, and where that story ends up is called Path of No Return, which sounds corny and cliched, but it reflects on Elon Musk's kind of thing that he's kind of like, people will die on Mars. I will take people to Mars. I will go to Mars myself, and I may well kind of die there, But actually, that ties into what the story is about, which is about, well, we're on the verge of this really amazing period of space exploration, this new phase of space exploration, where it's really opening up, and you've got private enterprises who can get into space. You've got, private citizens now who can train as astronauts, who can go into space. We're on the verge of something really big, but we need, in amongst all the excitement, we also need to be careful about what might be the downsides of that huge burst of activity, and that's something that again is a sort of spin on the story, which is a really exciting story about space exploration kind of opening up and us being on the verge of this terribly exciting period. But it's trying to look at it from a different angle and pose something different. So I really hope that what people would get from it is that kind of alternative kind of view on a whole bunch of this stuff. And if I may, just very quickly, the other thing is, obviously, hopefully you can see that I'm quite enthusiastic about all this, and that I really do believe that space and science and astronomy needs to be coupled with wonder and emotion and all this kind of stuff. It's a fundamental part of doing science and being interested in space, and I hope that really comes across in the book as well. And I think I said something in the foreword about if I can sort of make that link for anybody who's reading the book, then that will hopefully be a job well done.
Great. Well, I think you sold it really, really well. So
I'm off.
If you want to grab your copy of Short Stories of Space, head over to the Spacer website It's spacestore.co/books, and you'll see it right there. I mean, I only got my copy yesterday, so I'll be probably get through it in a couple of days. It doesn't seem kind of a really bulky read, so which is nice. So go get your copy, spacestore.co/books. And now I'm going to hand over to Piers, and let's have a look at some wonderful imagery. And I'll leave the stage to you.
Thanks very much. Okay, great. So I think what we're going to do in this next section is sort of run through a whole bunch of images that are associated with each of the stories in the book. And I'll try to talk through them a little bit, give you a sense of what I was trying to achieve with each of the stories, I suppose. So if we can crack on to the first slide, please. So the first story is called On the Right Shoulder of Orion. I've already talked about this, obviously, so I probably won't repeat everything that I said earlier about my personal connection to the stars. People will probably recognize, or plenty of people recognize, the constellation of Orion. We've got the sort of broad outline of it here. I mean, one of the amazing things about Orion is just the sheer number of really beautiful, kind of bright stars there are. You can see at the bottom section of this picture, the bright star on the right, as you're looking at it, is the blue supergiant Rigel. The star that was actually dimmed and people thought was going to explode is actually just cut off the top of this image. So it should be at the top of the image on the left, but that's Betelgeuse. But Orion is, as I say, one of those constellations that everybody recognizes. And there was huge excitement about the idea that Betelgeuse would explode. I found that, however, personally difficult, and that's what the story is about. If we just move on to the next slide, please. I mean, this is one of the. I just wanted to include this slide because this is one of the reasons that I found Orion so beautiful as well. I mean, not only does the constellation itself have a lot of really bright, beautiful stars in it, it actually has some really beautiful kind of examples of galactic nebulosity. So this is like clouds of gas and dust that occupy our galaxy, out of which stars are formed, and you can see that here in this sort of this much more kind of detailed image. This is actually the central region of Orion around Orion's belt. It's a bit harder to see that because actually, the way in which this photo has been taken wants to sort of draw attention to all the nebulosity. But I guess what I'm trying to do here is kind of say this is one of the reasons why I found Orion itself so beautiful. I thought that it was such a wonderful constellation. On to the next slide, please. And then this is Betelgeuse. So this was the star that began to dim. And Betelgeuse is an absolutely enormous star. So if it was placed where the sun is in our solar system, then we would be inside Betelgeuse's outer layers, basically, and its surface, so to speak, would extend quite a long way towards the orbit of Jupiter, actually. So it's an enormous star, and one of the incredible things about that is that you can actually image the star directly, and these are two side-by-side images of Betelgeuse early in January 2019, and you can see that it's very bright back in January 2019. And then in December 2019, you can see that the sort of lower section of the star's image is actually quite much darker. And so this led to spenumberation about what caused the dimming of the star. I'm not going to give away too much here, partly because I just don't have time, and number two, because hopefully you can read it in the book, and that'd be really interesting. As I say, the story itself overall, however, was about the dimming, but about then our sort of relationship with the stars themselves. Okay, on to the next slide, please. So the second story is called Where the Stars Shine the Clearest, and it's really the story of Hubble Space Telescope. People will be very familiar with Hubble, I'm absolutely sure. Hubble has been in space for now over 30 years. So last year was the 30th year anniversary of Hubble being in space, which is a really incredible achievement for a space telescope. And, there were lots of sort of autobiographies of the Hubble Space Telescope, as it were. One of the things I didn't feel I saw quite so much last year, if we move on to the next slide, was actually the story of, if we move on to the next slide, Yeah, these guys, Lyman Spitzer, the guy on the right, and Nancy Grace Roman, and these guys are basically the kind of the eponymous kind of mother and father of the Hubble Space Telescope. And so what I really wanted to explore in this story was the backstory to the Hubble Space Telescope, how Hubble went from a sort of concept that Lyman Spitzer actually developed into a workable idea. This idea of an observatory orbiting the Earth. How he sort of fought for the science behind Hubble Space Telescope, and about how Nancy Grace Roman, who was an absolutely formidable person, she was the first female executive in NASA, ended up kind of helping to really push the entire project through Congress, despite huge number of problems and issues, and how between them, over the course of 45 years, they managed to bring this concept of Hubble to life. I think it's just a really dramatic story, actually, but it's a really interesting story as well. And then, of course, what I also wanted to celebrate in this story, if we move on to the next slide, was actually Hubble's kind of role as an ambassador for space and astronomy. This image, which is of sort of towers of gas and dust in a nebula called the Eagle Nebula, was one of the early, like, really iconic images from Hubble. And this image was incredible because it's hard to see on the screen here, but you can really sort of see star formation happening in real time, as it were. You can see sort of locations of stars actually forming and then blowing away the outer layers of gas and dust out of which they actually form. If we move on to the next slide. But for me, one of Hubble's kind of, most enduring images was the Hubble Deep Field. And this is basically when Hubble stared at a single patch of sky for a long period of time. But it wasn't just any old patch of sky, it was the emptiest possible patch of sky that the science team for Hubble could find. And they just pointed Hubble at this empty patch for ages, and then saw what they could find. And what they found was this image, which is absolutely plastered with galaxies. And it was, this kind of image and the iconic image of the Pillars of Creation before, as I said previously, I think go back to this idea that, well, space and astronomy is a really human kind of science. It fundamentally, places us in the universe and kind of defines our sort of place in the universe. And I can't help but look at this image and sort of think about that. So again, the whole story of Hubble's legacy explores not only how Hubble came to being, but the sort of the legacy that is left for science and for humankind, I guess. Next slide, please. We then move on to the unpredictable constant. And this guy, whose nose is unfortunately covered by the title of this story, is Edwin Hubble. And he was the guy who really established the idea or provided the observational basis for the expanding universe. If we just quickly skip on to the next slide, please. What Hubble did was he actually looked at galaxies at different distances from us, and he related their distances to the speed at which they were moving away from us. And what he found, this relationship shows that the further away a galaxy is from us, the faster it's moving. And this simple sounding observation is actually something that led to the idea of the expanding universe. I mean, the idea of this expanding universe was around before that, but this really provided the first solid kind of evidence in favor of the expanding universe. But the universe is expanding, and its expansion rate can be characterized by a certain parameter, which we call the Hubble constant. And that Hubble constant is really essential to all our models of the universe's history and evolution. And really what this story is about a growing problem for cosmology, which has been growing over the past kind of 15, 20 years, which is about what the expansion rate of the universe, this value called Hubble's constant, actually is. And if we jump onto the next slide, what you see here is a galaxy, but the object that looks like a star, a bright star in the bottom left, is actually an exploding star in that galaxy. So this galaxy is hundreds of millions of light years away from us. But the bright point light object you see in bottom left is actually a star within that galaxy, which has exploded. Now, it just so happens that actually a lot of these types of supernovae, these exploding stars, help us to actually determine distances in the universe. And when I said the Hubble related the distance of galaxies to the speed of their the speed at which they're moving away from us, these kind of measurements are really essential to determining how far away galaxies are, how quickly they're moving, and therefore what the expansion rate of the universe is. And the problem is that if you try to calculate the expansion rate of the universe based on these kind of observations, supernovae, they actually don't agree with the calculations of the expansion rate of the universe using other observations of the very early universe. So if we move on to the next slide, this is an image of the very earliest period of the universe's history. It's light from around 300 years after the start of the universe. And prior to this period, the universe was actually opaque. So you couldn't actually see between different regions in the universe. So this is the earliest image we can take of the universe. And the thing is that cosmologists and scientists know what the science is that goes into the production of this picture. So they think they know what all the physics was at the start of the universe. And that physics determines what this picture actually looks like. And all that physics can be combined to predict what the expansion rate of the universe should be. And as I say, when they do that and they try and determine the expansion rate of the universe today based upon this cosmic microwave background radiation, they find out that it's actually very different to the value that you expect just based upon supernova studies. And so this story is all about the discrepancy between those two values. And the idea that cosmology itself is now actually at a bit of a turning point. So our understanding of the evolution and history of the universe is at a bit of a turning point where we are seeing certain cracks starting to emerge from a picture that at one time was actually really rock stable, and everybody felt as though they understood, how the universe operated, how it evolved. And we're now starting to see fault lines in that a little bit. And actually, I think that's really exciting because it tells us that we're moving forward in our knowledge. So it's a bit of a crisis for the cosmological community, and it has been and has continued to be a crisis. But I think it's good for science, and this story is about all that. If we can move on to the next slide. Okay, then we come to a story which I've called Earth's Unlikely Twin. And this is really about our two closest planetary neighbors in the solar system. So I'm sure many of you will recognize the planets on the left as you look at the screen, which is Mars. The planet on the right is Venus. But actually, this is an image of Venus taken with radar, because Venus has an extremely thick atmosphere, so you can't see through to its surface using visible light. But this is a side-by-side comparison of our two nearest neighbors. And this is, I really enjoyed writing the story, because the sort of event or the topic that triggered it was actually the detection of a certain molecule in Venus's atmosphere called phosphine. And phosphine on Earth is very much associated with life. It's never been found in any other situation other than a situation where there is life. And Venus itself is an incredibly inhospitable place. It's like hell on Earth. Forgive the pun. It's like hell. There you go. And it's the last place in the solar system that we would expect to find life, except for a very small region of Venus's atmosphere where temperatures and pressures are actually quite similar to those on the surface of the Earth. In any case, we still don't expect there to be life on Venus. And so when phosphine was discovered, everybody got really excited about it. And people got excited about the idea of life actually elsewhere in the solar system, but on Venus. Now, originally I was going to write about that, but actually where I went with this story was trying to understand actually what had made both Mars and Venus so inhospitable to life. And in the process of that, one of the things that I discovered, or one of the things I was reminded of, was that actually in the early solar system, probably had 3 habitable planets. There's Mars, there's Earth, and Venus. Venus could also have been habitable in the early solar system. And over time, both Mars and Venus have become incredibly inhospitable. And now we're just left with Earth as being the whole, the sole kind of hospitable place for life in the solar system. And so this piece of writing that had started off talking about phosphine and the possible detection of phosphine in the atmosphere of Venus, then sort of transformed into a story about, life in the solar system and how actually, the opportunities for life to exist in the solar system have really narrowed. And for me, what that means is that, the Earth is precious, basically. And this is another way of expressing how precious the Earth actually is. And so the story kind of explores that theme, explores a lot of the science behind that, about how Mars and Venus became the way they were. And it also talks about phosphine, and it talks about the detection, or the so-called detection of it last year as well. Okay, if we can move on to the next slide. Oh, I forgot to talk about this. Never mind this one. Let's move on to the next one. Okay, and then we have a story which is basically about how our perception of the universe has actually changed through time. So through the history and the annals of astronomy. Because last year was 100 years since the so-called Great Debate. It wasn't the greatest debate, but it was called the Great Debate. Between these 2 gentlemen, Mr. Harlow Shapley on the left, and then slightly intimidating-looking Heber Curtis on the right. And essentially, this debate took place, 101 years ago now, but the nature of the debate was about whether or not these objects that astronomers had started to see in their telescopes, which were little spiral forms in the night sky, that they referred to as spiral nebulae, whether they were part of our own Milky Way galaxy, or whether they were actually outside of our Milky Way galaxy and existed as their own island universes elsewhere in a much larger universe. And the reason I found this really interesting was that actually that debate, this kind of subject, this controversy, was actually all about how we perceive the universe as a whole. So, our universe has undergone a multiple series of sort of paradigm shifts throughout the history of astronomy. And this was actually, one of those moments where we went from a universe that we understood to be completely contained by our Milky Way to, as happened after the Great Debate, a universe that was much bigger and in which our Milky Way was only one of a huge multitude of other galaxies. But the Great Debate between Harlow Shapley and Heber Curtis was kind of a pivot point for that discussion. And that's why I really wanted to sort of explore it, celebrate it, understand it. Next slide, please. Okay, so the penultimate story is about living with solar storms. And we mentioned a little bit earlier about aurorae. So I'm sure people will recognize the Aurora Borealis, or the Aurora Australis if you're in the south. These beautiful kind of light displays in the sky, which are basically fed as a result of the interaction between the sun's weather and the solar wind, which is a stream of charged particles and magnetic fields that exits from the sun and streams throughout the solar system, and our Earth environment, basically. And these aurorae are really beautiful, obviously. So this is a really beautiful kind of demonstration of how the sun and the earth are actually linked in a dynamic kind of way within the environment of the solar system. But there's a sort of there's a dangerous side to it, as it were. So if we move on to the next slide. So what we see here are a bunch of images of the sun's surface, and the bright spot that you see in sort of top left of each of these images is actually was known as a solar flare. So it's a sort of explosion, essentially, which happens in the sun's atmosphere. And what happens as a result of these explosions is that you get a real outburst of charged particles and radiation that gets flung out into space, and it's got an incredible amount of energy associated with it. And what this story was looking at was, it was actually picking up on some research that was being done last year, looking at a way of trying to predict these flares and predict when these explosions in the sun's atmosphere may actually happen. And the reason that's interesting is because these can really actually damage not only the satellite networks that we depend upon for our modern day kind of technological life, but also things on the ground. So things like power grids can really be put in danger as a result of space weather, as a result of the sun's activity. And if we just move on to the next slide. Yeah, here's an example of just how kind of fierce and chaotic the surface of the sun actually is. And sort of, I love this image. It's not only is it beautiful, but it captures the idea of how much energy there is in the surface of the sun, and when that energy gets directed at Earth, just how vulnerable we are to its kind of destructive influence. So this story was exploring a particular piece of research about trying to predict solar flares and how we might be able to protect the Earth in future. Okay, if we can move on to the next slide. Wow, this is hard work. Okay, this is the final story, and it's about, so I referred to it earlier, it's the Path of No Return. It was inspired by SpaceX's launch of the Crew Dragon, so the first private vehicle to deliver astronauts to the International Space Station last year. And again, I think I said some of this earlier on, but you know, the really important and interesting things for me about this is that we are now on the cusp of a huge shift in space exploration and how space exploration takes place, and that's incredibly exciting. So we've now got private companies who are involved in space exploration. We have even private citizens who can train to become astronauts and be sent into space. And it's only a matter of time before things like mining of resources from asteroids or from the moon, you know, become a sort of a daily activity and something that people make money from. And there's a huge amount that is very exciting about this future. There's also, however, in my opinion, a complete lack of conversation about what some of the downsides of this future could be. And if you just move on to the next slide. I mean, in this story, I basically explore some of the downsides of possibly mining for resources on the moon. So this is a lovely picture of where different types of resources and minerals are located on the moon. If we move on to the next slide. And also some of the ethical questions that we're going to have to face in the future as we're faced with this much, you know, greatly expanded sort of capability to explore space. So this image you see on here, not exactly this image, but a sort of straight line version of this image was actually the background of Elon Musk's Twitter feed for quite a long time. I don't know whether it still is actually, but Elon Musk has made no, you know, has not sought to hide in any way his ambition to colonize Mars. To become the first ruler of Mars. No, I don't think he said that. You know, but has sort of talked about the ambition of actually terraforming Mars. And this is a really interesting question for me, because we've talked already about how Mars may have held life in the past. And, you know, if we do not know whether life exists on Mars, there's a question for me about whether we have the right to try and change the environment of Mars and potentially endanger any relic kind of organisms or life that still exists on Mars today, even if though it may just be microbial. So, that's for me is a really interesting question. It doesn't mean that we should stop trying to get to Mars and trying to do stuff on Mars. Absolutely not. But it's a question which I feel we should be asking and we aren't asking at the moment. So this last story was really about sort of exploring the future of space exploration and some of the really tricky things that we may have to face up to and talk about in the future, and perhaps that we should be facing up to right now. Whew, okay, that was hard, but good and fun. This isn't the end of the entire conversation, but thank you for watching that set of slides.
We can hide that slide for the moment. But yeah, thanks so much for talking through all of those chapters. I'm sure those will make for great snippets on our social media later on. So if you don't follow Space Store on Instagram and Facebook and Twitter, make sure you go and follow those channels so you can keep up to date. We've got a few questions in from the audience, actually, and they're asking, what was your favorite chapter to write? Now, you've spoken about them for the past 20 minutes. What was your favorite one? You can't pick the first one, by the way, because we've spoken extensively about that.
Okay, I'm not going to pick the first one. I think that last one, actually, The Path of No Return, do you know, it started off the one I was kind of like, I'm not sure where this is going to go. But actually, I found it really interesting to write. And, space exploration wasn't something I was that much of an expert in. But actually, the amount that I was able to learn, and it's fascinating. Again, just the breadth and the scope of it. We are going to have to face up to some really interesting questions in future about society. If we have an actual a city with 1 million residents on Mars by 2050, there's a really interesting societal question in itself. Never mind the sort of ethical questions about whether we have the right to actually try and terraform, or whether we have the right to actually kind of mine minerals from asteroids or the moon surface. So actually, I think that was one of my favorites.
Great. And just a question on that from Jamie in the audience. He's asking, how realistic do you think Musk's time frame is for Mars?
I mean, to be fair, Musk is obviously a very driven and is a visionary, right? And he's achieved almost exactly what he said he wanted to achieve. Or unrealistic, yeah, absolutely. I mean, the point is that if I had to answer that question, which is, I don't think it is. I think it's a crazy timescale. I mean, he's talked about shipping, hundreds of thousands of rockets of the Starliners over to Mars in order to make this happen. I mean, that's an incredible venture. And once you get there, to be able to establish a base that is going to, continue to be sustainable, I think is ludicrous. But on the other hand, he's actually making real, strong, and fast progress. It's funny because I think 2 years ago I'd have said no, it's just crazy. And now I'm a little bit more like, but I wouldn't bet against him at the same time.
Great, yeah. Well, we've talked a lot about kind of what's in the book. Let's chat a little bit about kind of the journey of writing it. How was that? How was the journey of writing it through 2020, which everyone knows wasn't the easiest of years?
Exactly. I moved to Amsterdam in the middle of it as well, so that was an extra kind of difficulty. But it was tough. I mean, I had to write a thesis, obviously, for my PhD, for my doctorate back in the day, and that was hard. Yeah. But this was also incredibly hard, and there's so much, all the things you associate with writing, the difficulty dealing with procrastination, blocking out time, and then managing to do nothing with that time, frustrating. There's a huge amount of actual resilience that is needed in order to write these books, which is not me patting myself on the back, but it's just, that was actually really difficult. And it was a really steep learning curve throughout that year to be able to fit the time in, be able to do the sort of editorial stuff, find a really great cover for the book, and there I was really lucky. A guy called Wouter Verhessen was able to provide us with an image for the cover of the book, which is absolutely fantastic. I think it's actually an amateur photo, but if you look at it, I mean, it doesn't look like an amateur photo at all. And I think that's a real credit to the quality of amateur photography. But it was very tough. Yeah, very tough.
And then you said you kind of took a break from research. Were you working at the same time whilst writing, or?
Yes, I was. So in my other life, I work for the government actually, and I've done that for quite a long time. While obviously, remaining in touch with all the astronomy stuff, I would absolutely love to be a full-time writer, but that's a long-term ambition, and so I'm not quite there yet.
Yeah. What? Because we have quite a few young professionals who are part of the space industry tune into Space Door Live. What would you say to those who might be thinking of writing a book?
Oh my goodness! Well, if you have the passion, and if you have a message that you just feel really really strongly about, then I think it's a great idea. I mean, writing a book, half of it is obviously about wanting to tell the world a story. Half of it is also about your own sense of kind of, I want to write this down. There's something really important about it. And I think it's a great way for people to sort of digest ideas, to work through ideas, to work through kind of, arguments and concepts and whatever. It's fantastic. I would recommend it. It's just not easy. That's the only thing.
Great. Well, a few more questions from me. And again, if you're tuning in tonight, let us know if you have any questions. We'll try and get to them before the end. We've had a few authors on Space Door Live over the past year and a half. And I always like to ask a question that, what do you think makes a good science book? Because it's more than just kind of repeating facts that you would find on Wikipedia. How do you make a good science book?
Yeah. Well, I mean, one thing which hopefully I've managed to portray or bring across, and so far, is that you absolutely need to have some passion, some sense of that kind of emotion that lies behind the science.
Yeah.
I always love that. I love the idea that you can tie the science back to real things, to real emotions, to real feelings, to real passion, and or kind of set it within a broader context, either of history or politics or society in general or philosophy. I always find that really fascinating and really good.
Mm-hmm.
But I think that the other thing is just being able to actually explain the science clearly without dumbing it down. I really hate it when people sort of write popular science books, but they totally dumb down the concepts.
Yeah.
And they do it for a reason. They do it to sort of try and make sure that it's engaging.
Right.
But I think sometimes there's a real skill in terms of being able to actually discuss really complex ideas in straightforward, illustrative, in capturing kind of ways. And I certainly won't say that I've nailed that skill, but it's something I would like to be able to work towards with my writing as well. Yeah.
Great. No, I'm sure you must have done a great job. When you say, just picking up on that, when you say kind of not trying to dumb it down, is that kind of the best way to do that, through kind of analogies, or how do you go about it?
I think this is a really good question, which I might not want to expand on it too much.
Sure.
But I mean, I think analogies are really useful. Analogies can be dangerous as well.
Yeah.
And sometimes they give too simplistic an idea of a physical situation, let's say, or a theory. And they're helpful for communicating a message and communicating the basis of an idea. But then where you take that analogy later, can actually then be quite damaging to your understanding of the theory. Sorry, that's not necessarily the clearest answer, but I mean, for me, as I say, some of it here is just about treating the reader, as an intelligent reader, and not being, giving giving the reader the empowerment that actually you can understand this, and it's not just rocket science, which it's also rocket science, but you know what I mean, really kind of supporting, I suppose, the readers to be able to actually understand some of these issues as well.
Of course, and I think you answered that question really, really well.
Thank you.
Great. Well, just on a final note, this is the first, but it's definitely not the end, is it?
Well, no, absolutely. I mean, Short Stories of Space is intended to be a series. What I'd like to be able to do is be able to do one of these each year. That's the aim.
Okay.
Sort of make it a sort of regular event, really, I suppose. There's other stuff I would love to write about as well. There's, again, if we think of some of the really big topics over the next decade, I mean, the James Webb Space Telescope, which is going to be the replacement for Hubble, as it were, or the telescope that supersedes Hubble, due to be launched in December. That's going to be a really incredible kind of new phase in astronomy. And one of the things that people are so excited about is about the idea of detecting life on exoplanets in other stellar systems, and searching for biosignatures, which are the sort of the spectral characteristics and fingerprints of life on planets in other stellar systems. And there's a book I would love to be able to write, which is looking at how likely it is that life exists elsewhere in the universe. And usually this conversation is about there's a heck of a lot of stars out there, and a huge number of places where life could exist. And you kind of go, well, that's life must exist out there. What is less explored, I think, is the alternative, or the flip side to that debate, which is about, well, just how hard is it for life to actually get started? And what is the probability that on any individual planet, you will get life emerging? And I'd really love to be able to write a book about that doesn't take sides. It just seeks to slightly kind of balance that debate a little bit and get away from quite a simplistic view, which is just there's a heck of a lot of stars out there and a heck of a lot of planets, and it just has to happen somewhere.
Yeah, I'm not sure if it's the Drake equation.
The Drake, well, yes, so the Drake equation, I don't think is particularly scientific. No. I don't think ever intended to be scientific. It was intended to generate a conversation. But yeah, you're right. The Drake equation was intended to sort of try and estimate how many advanced civilizations you should be in the universe. Yeah.
Great. Well, thanks for that. It's been an absolute pleasure speaking to you. Once again, go ahead, head over to the Space Door website, spacedore.co/books to grab